Okay, so we have our matrix here in row echelon form, and we are working to get it to reduce row echelon form. So we have to eliminate the values that are non-zero in the columns. So the first value I'm going to try to eliminate is the 2/3 here. So I'm going to do this by row operations, and you're going to see I'm a little slow at it, and so we're going to see soon how to do this with computers to make life a little more efficient. So I am going to subtract 2/3 of row 2 from row 1. So I'll keep row 1 just like this. And then I'm going to multiply row 2 by 2/3. So it's going to give me still 0. My negative 2/3 here that I want. And then I have to multiply 3/2 by negative 2/3. So this is going to be -1, I believe. And then 2 times negative 2/3, that I believe will be negative 4/3. So then I end up for my new row 2 with 1, 0. I think this gives me -1/2. And then here, do I end up with, is this a 0? It looks like the 0's out. Okay, so my new row 1 is looking a little bit better here. So the new row 1 is now 1, 0, negative 1/2, 0. My row 2 is still the same. And my row 3 is now 0, 0, 1, and 2. So now I want to get rid of the negative 1/2 here in row 1. So I am going to take row 1 and add to it half of row 2. I'm going to have 0, 1, 0, negative half, 0, and I'm going to add to it, I'm sorry, half of row 3. So I'm going to have 0, 0, 1/2, and 1. And so this gives me my new row 1, which is 1, 0, 0, and 1. This is my new revised matrix. I've got 1, 0, 0, 1 in the top row. And then the second row is still 0, 1, 3/2, and 2. And the bottom row is 0, 0, 1, and 2. So our next move is to get a 0 here in place of the 3/2. We're in row echelon form, and we're working towards reduced row echelon form. And again, we're normally going to outsource this to a computer, so I will show you how to do that. So the way that we would do this algebraically here is take row 2 and subtract 3/2 times row 3. So that'll give us 0, 0, negative 3/2. And then 2 times negative 3/2 is going to be negative 3. So if we total this up, we get 0, 1, 0, and negative 1. So now our matrix is in this form, 1, 0, 0, 1. And now our second row is 0, 1, 0, negative 1. And our third row is 0, 0, 1, 2. So phew, we are now in what is known as reduced row echelon form. Oh, I got an extra W in there. So let's go back to this slide I have here and talk about when is a matrix in row echelon form and when is a matrix in reduced row echelon form. So as I said earlier in the previous video, a matrix is in row echelon form when any rows consisting entirely of zeros are at the bottom of the matrix. So if we look over at this matrix, there are no rows that are entirely zero. Our next criteria is that each row that does not consist entirely of zeros, the first non-zero entry is a 1. So that's what we've got here on our diagonal. All ones right there. And then the third criteria is that the leading one in the highest row is furthest to the left. So we get that triangular or staircase pattern here. So we have that here. And then we can say the matrix is in reduced row echelon form when every column that has a leading 1 in it has zeros everywhere else. So if you look at column 1 here, it has 0 in every column except, we would call this 1, 1, the entry position in the matrix. If you look at column 2, it has zeros every place except entry 2, 1. We'd call that entry 2, 1 because it's row, 2, 2, row 2, column 2. And then for column 3 here, we have a 1 in position 3, 3, right on the diagonal, and zeros everywhere else. So remember, this last row is our augmented solution column vector, so that's just fine, as is to have any value in there. All right, so that's the definition. So let's test our understanding of the definition. So here are 3 matrices I've written out, and I want to analyze, are they in row echelon form or not? And then if they're in row echelon form, are they in reduced row echelon form or not? So matrix A here looks like it satisfies all 3 conditions in the definition of row echelon form. So if we go back a slide, we see our conditions are that any rows consisting entirely of zeros are at the bottom. So if we look at this matrix, the row of zeros is down there at the bottom. Our second criteria is that for each other non-zero row, the leading entry is 1. And so for rows 2 and 3, the leading entries are 1. And our third criteria is that the leading 1 in the higher row is further to the left, which is definitely the case. Row 1 has the leftmost 1 here. So we can say this matrix is in reduced row echelon form as well, because if you look at each column here, with leading coefficients, there are zeros everywhere else in those columns. All right, what about matrix B? Does that in row echelon form? So if we look at the non-zero rows, look at row 1, column 1, that leading value is not a 1, it's a 2. So we would say that this is not even in row echelon form. And then let's look at matrix C. So matrix C has a non-zero row here. This first row here, let me change colors, is problematic right here because the leading term is a 0, not a 1. So these 2 columns right here that are zeros are problematic. This is not in row echelon form. Okay, we will look next at some examples of how to use technology to find reduced row echelon form, because you can see that it is a bit time consuming trying to do it by hand through algebra, and we want to make use of technology.